potentially holding the key to one of the major ways of addressing the need for a deeply decarbonized energy system.
I really see nuclear power as being critical to the future of the planet. It's about my kids, it's about making sure that they actually have a planet that's cool enough to live on.
Nuclear engineering is an opportunity to impact a lot of different parts of society.
The conversation is changing. The world is giving nuclear energy a clear-eyed look as we count the costs of fossil fuels and recognize the vital role clean power plays in improving lives.
We know fusion ignition works. We know that the sun is burning right now and giving us all our energy we need from fusion reactions. And what we want to do is create that in the laboratory environment for an application that could have a significant impact on society.
We are training the workforce and developing the technologies that ensure that defense treaties are enforced.
Here at the University of Michigan, we have a consortium for verification technology to help create the workforce for preventing the spread of nuclear weapons around the world. Students have a leading role to play in the research projects, and so they can develop new detection systems that will help verify nuclear treaties.
A new generation of entrepreneurs is developing smaller reactors that could provide power in remote locations, or work together with clean energy hubs.
Because of the relatively low capital cost for the construction of small modular reactors, because of their capability of providing electricity to small grids, and being able to locate in remote areas, being able to work with other energy sources such as the wind and the solar. Most likely these small modular reactors will be built in the next wave of nuclear power plants in this country and perhaps also worldwide.
We're saving lives by targeting cancers with radiation.
We treat patients with different types of radiation, and there are a lot of physical aspects and things that we can do to localize the cancer, to learn more about the cancer, and then to use radiation in different ways to treat patients so that we can hopefully use radiation to kill the cancer cells while sparing as much of the normal healthy tissue as possible, and so we can give that patient a better chance for a cure.
And we use nuclear technology to solve environmental problems like cleaning polluted water.
When plasma comes in contact with water, it generates these reactive chemicals that attack bacteria contamination, viral contamination, and it reduces them to gas and water vapor. And so there's nothing essentially left after the treatment. Using plasmas for water treatment, it gives students, they get a chance to get exposed to real-world problems and real-world solutions featuring advanced technologies such as plasma.
At the University of Michigan, we promised to honor the deaths of those who fought in World War II by developing peaceful atomic technologies with the Michigan Memorial Phoenix Project.
Since nuclear energy had ended that war with Hiroshima, they decided to essentially use the peaceful uses of atomic energy as their goal. It led to a major investment in laboratories, the first nuclear reactor on a campus, and really created a whole new number of sciences that were the backbone later of the application of peaceful uses of atomic energy.
And like the Phoenix, we are reinventing what it means to be a nuclear engineer.
When most people think about nuclear engineering, they think about power production. But in Michigan, we think it's much more. It includes advanced physics studies using ultra-fast lasers and high-density plasmas. It involves cutting-edge radiation detection equipment for medical applications and for nuclear security applications. And it involves hosting world-class facilities for understanding materials under extreme conditions. Finally, it involves partnering with our colleagues in the Michigan Energy Institute to study the economics, public policy, and social science applications of deploying advanced energy.
We are the nation's top nuclear engineering department. And we are building the leaders who will drive the world's energy future. Nuclear Engineering and Radiological Sciences at Michigan.